Hey guys, this week we're going to be doing a review on Unit 6 and Unit 7. So you're going to take some notes just to review, and then you're going to do a Go formative assessment on it. So let's first talk about Unit 6. This was all about polynomials. And one of the first thing we did with polynomials was we classified them. We said we would classify by degree, which is your highest exponent. And we would classify by term, or number of terms. So let's look at an example. Let's say I have 10x to the third minus 4x plus 3x to the third plus 9y. When you classify, you have to combine like terms first. That's super important. So, for example, if I didn't combine like terms here, I would say that there would be 1, 2, 3, 4 terms, and I would say this is a polynomial. But because I have x to the third here and x to the third here, I can combine those two. So 10 plus 3 is 13, x to the third. Then I can't combine the x or the y, so I would just write minus 4x plus 9y. Now, my highest exponent is 3, so that's cubic, and I have 1, 2, 3 terms. That's a trinomial. It was probably at the beginning of your notebook. You should have a foldable that we put in there that has that lists all of the different terms. So you have constant, or excuse me, terms would be monomial, binomial, trinomial, and polynomial. And then for your degree, you would go constant. Linear would be 1. So for example, if you had something like 10x plus 4, this is x to the first power, so that would be linear, even though we don't write x to the first. And you'd have 1, 2 terms, so that would be a binomial. Linear, then quadratic. Cubic is for 3, and quartic is for 4. So quar and 4 rhyme. Quadratic is for 2. We also talked about combining like terms like this, but we had a problem that looks something like this. Let's say we had 6h squared plus 3 minus 4h squared plus 7h minus 1. So there's a couple ways that you could do this problem, but what you have to remember is that this minus sign has to apply to everything in these parentheses. So what you could do is just make this a plus, and this becomes negative 4h squared. This becomes negative 7h, and this becomes plus 1, because when this was a negative, let me just show you again. So negative times a positive is a negative. Negative times a positive is a negative. Negative times a negative is a positive. Now you can combine your like terms. So 6h squared minus 4h squared would be 2h squared. You don't have anything with the 3, but we have a minus 7h here. I'm sorry, we do have something with the 3. We have a positive 3 and a positive 1, so that's plus 4. And that's how you'd combine those like terms. All right, let's talk about radical equations. So in a radical equation, we had something like this. Let's say we have 2x plus 4, and I'm going to make this a little smaller here so you can see right on the outside, minus 1 equals, let's just do 7. So inside the radical, I can't do anything until I get rid of this radical. But I can't get rid of this radical until I take care of this positive 1. So you can't get rid of the radical if there's something out here that you're multiplying by, or if you're adding or subtracting. So your first step is to add 1 to both sides. So now you have the square root of 2x plus 4 equals 8. There's nothing that I'm multiplying by. There's nothing I'm adding or subtracting. So at this point, I can go ahead and square both sides. When I square both sides, nothing happens under here. This just becomes 2x plus 4. The radical just goes away. So to undo the radical, we square it. Then 8 squared is 64. Now I have a regular equation just like I always have. So I'm going to subtract 4 on both sides. So I'm going to get 2x equals 60. Then divide by 2, x equals 30. All right, let's go ahead and talk about end behavior now. We did a chart where we talked about the highest exponent and the if you had a positive or negative coefficient. So for example, if I had something like y equals x squared, my highest exponent is even, so 2 is even, and right in here, that's a plus 1, so that is a positive coefficient. So when I graph this, my end behavior here, they're both going to be going up. So as x approaches positive infinity, as I go out to positive infinity, my graph goes up to positive infinity. And as x approaches negative infinity, my graph also goes to positive infinity. So as I come out to negative, I go positive, positive, I go negative. So if you have a positive, an even exponent and a positive coefficient, the number in front, you know eventually your graph would look like this. Even if you had something like this, y equals 3x to the 100, let's say. You may not know what's happening inside the graph, but you know at the end, it's going to both go up like this. This can be going all over the place, but you are going to be going to positive infinity. For example, if you had something like this, y equals negative, let's say 2x to the 6, then they'd both be going to negative infinity. And if you have y equals, let's say 5x to the 7th, so now these are both even, these were all even. If we had an odd exponent, and this is positive, as we come out to positive infinity, we're going to go to positive infinity. And as we come out to negative infinity, we're going to go to negative infinity. Again, what happens in the middle, we don't really care about. We just know that as x approaches positive infinity, f of x also approaches positive. And as x approaches negative infinity, the graph goes to negative infinity. And then the opposite would be true if we had a negative coefficient and an odd, so let's say 9, exponent. It would be, as we go to positive infinity here, we would go negative, and this would go positive. So again, it could do whatever we want here, but it would just be the opposite of the positive there. All right, let's go ahead and talk about factoring and zeros of a function. So let's say that we have f of x equals 3x minus 2, and we have x squared plus 6x plus 8. So I want to go ahead and factor here and find the zeros. When you're factoring, you're doing the opposite of multiplication. So we're not going to multiply these out. We're going to take a look at each individual set of parentheses and we're going to see if we can factor it. When I look at 3x minus 2, I can't do anything to it. So that's just going to stay as 3x minus 2. But here I have a trinomial. There's nothing I can take out of it. There's no greatest common factor. It's not the difference of two perfect squares, so I'm going to look to see if I can find two numbers that multiply to 8 and add to 6. So I'm going to look at my factors of 8. I've got 1 and 8, 2 and 4. Well, 2 and 4, if I make them both positive, they add to 6, and 2 times 4 multiply to 8. So this can be rewritten as x plus 2 times x plus 4, just taking these numbers here. So that's factoring it. If I want to find the zeros, I have to take each one of them and set them equal to 0. So I take each factor and make an equation equal to 0, and then I'm going to go ahead and solve for x in each one. So add 2 here. So I get 3x equals 2. And then divide by 3. So x equals 2/3. So that's 1 0. Here I'm going to subtract 2 from both sides. So x equals -2. So that's another 0. And here I would subtract 4 from both sides. So x equals -4. So that's my final 0. Okay, we've got 2 more problems to do. The first one is actually pretty easy. This was where we talked about transformations. So remember we said if a move is inside the parentheses, the square root, the exponent, that move is going to be left or right, depending on the sign. A positive move is left, a negative move is right. So for example, if I had f of x equals the square root of x plus 7, from the parent function, this would move left 7. If we have the number outside of the parentheses or the square root or the exponent, that is going to be an up or down move depending on the sign. So we've got an up move is positive and a down is negative. So something like this, if I had f of x equals the square root of x minus 9, this would be a move down. Let's go ahead and combine that. So let's say I have something like f of x equals x plus 4 squared minus 2. This would be left 4, down 2. That should be a review from your Math 2 class as well. Okay, our last problem is going to be about synthetic division. So let's say that we're given a function. So, given a function, f of x equals, and let's say we have, I probably should have come up with this ahead of time. All right, so let's say we have x to the third plus 5x squared minus 8x minus 12. I'm hoping that will work. So we're going to have this function, and let's prove that x plus 1 is a factor. Okay, so when we have this form, when we have a binomial form here, remember binomial is 1, 2 terms, we do have to change the sign here. So I'm going to make that a -1, and then we're going to draw kind of that big L shape that we did. Then we're going to take the coefficients from here. So even though it's not written here, there's a 1 in front of here, so I would put a 1, then 5, -8, and -12. So I'm just taking the numbers that are in front of the variables and then our last number. So with synthetic division, we always bring down the first number. Then we're going to follow that V shape. -1 times 1 is -1. And we're going to combine our like terms going down, or combine our terms going down, so 5 minus 1 is 4. -1, so we come back over here, times 4. We're going to put -4. Sorry, that was my cat. So, and we're going to combine our like terms coming down here, and we get -12. -1 times -12 is a positive 12, which is 0. And because the remainder is 0, we know that x plus 1 is a factor. All right, go ahead and try that Go formative. Hop on a Zoom call if you have any questions or send an email. Thanks. Bye.